scour blowers, they have to be auto. If they're off, we're going to get an alarm saying, hey, blower's not available. You can hit the start there. It'll just say blower's not available alarm, and you'll get a fault. The rest of the system, so it doesn't really care what's going on. As long as we have water, it'll run. If it doesn't have water, it just goes into the thing and it's just standby. So we got that signal, and so we should be able to go ahead. So step one, if you're not logged in, all grayed out, so you can't do anything. You can't mode control, you can't turn anything on, it's just all grayed out. So step one, you have to log in. 2222 is the login for Super. So that allows you to, Super login allows you to do a few more things than the operator login. So you've got a graphic, numbers and all that. Overview tells you what's going on in the system. So the aerobic zone looks like mixtures are going, your restart pump, D-night pump's running. And it says here, systems off. So the membrane trains are off. Other screens, you have the air compressor screen. So duty time, it doesn't look like air compressor run very much. So there's your lead lag. So if you press that, so right now device one's in lead, the other guy. So daily rotation at enabled. So if you disable that, it'll just keep the compressor 2 in lead. So right now it's just set to rotate at midnight, and you have to enable that screen. So that's like any of the motors or the thing if you got 2. So now you got the green is running, valve green is open. If it's grayed out, it's closed. So here's your pressure switches. If they're highlighted, it'll show a fault in there. If they're got a bit of a color to them, they'll say, hey, we got pressure switch low or pressure switch low. Bioreactor 1 and 2. So I've got here pre-anoxic tank mixer running, D-night pumps running, 281 gallons. So you can see all that information there. Now, for some reason, Keith's got these. So the blue means it's in override. So basically, you can put simulate, and then you can put in a number. So if I put in 2, it'll just display 2 on there. I'm not sure why it's got it in simulate mode, but I'm going to leave it for now. So yeah, you've got your pH and your DO levels. Now all these FICs or whatever, any of the PID loops. So here we've got a set point of 281. Our process variable is 280, so it's pretty well matching the PID. Gives you your speed. If you put it in manual, you can punch in 70, and then you'll see that flow rate drop. But the normal operation, so now it's running at 70 instead of trying to match the PID. So if it's control mode, you really want an auto, and now it'll speed up to get back up to the set point. What other curious things there are here? A lot more things. So in DO control, so if you hit DO control, there's 2 modes, DO control or cycle mode. So DO control is it's trying to maintain a set point. So it goes at a certain starting speed, and then it adjusts itself to try to maintain. Now if you go in the cycle mode, it's going to go based on a timer. So if you hit cycle, it will then duration and interval, so it'll run 90 seconds every 1800 seconds. Sometimes because the DO control, especially at the start, you just don't have enough bacteria in there. The DO just goes sky high because there's just not enough food and bacteria to use up that thing. So that's why sometimes at the start you'll want to use cyclic control, because you're just going to give it a bit of oxygen and then let it use up and then add some more. Because otherwise, there's certain minimum speeds on blowers. So even at the minimum speed with low bacteria, low food, it just doesn't use it up. So the DO goes up. So that's typically once everything's established, you'll probably want to run DO control rather than cyclic control. But they're available for you. If you want to disable bioreactors, you can disable bioreactor 1, 2, so it doesn't take into account the levels in there or the pHs and all that. So you got those kind of extra things there to look at. So same thing with your chemical dosing. You want to enable micro C dosing, yes. If here we got some sort of fault, so you can probably do the same thing for pH. If you don't want to have sodium hydroxide, you can probably disable that. But there's a lot of things going on in here. So we've got from the process blowers, you're adding air here. You got RAS coming in. So anything that's got grayed out, you can't go there. There's no direct thing. But if you got anything with the black thing, it'll take you to that particular screen. So if you want to go back to bioreactor 1, 2, come on, you'll lag with me there. Takes you back to bioreactor 1, 2. So here you can go to UF1, and that takes you to UF1. Again, all these valves, when you're logged in as Super, you can put things in manual. You want to open up the valve, we're going to open up that one. So if you want to run the ejector valve, manual, so the hand's the manual signal, that's open and that's closed. And then auto. So any of the valves, any of the pumps, you can put in manual when you're logged in as Super. Again, he's got the turbidity on simulate mode. It's not reading a real turbidity. Not sure what's going on. Why is this out of range? Oh, interesting. Oh no, there we go. So the actual, so if you take it out of simulate, it's going to display the actual 1.42. Now, sometimes you want to put in simulate so you don't get some weird alarms. Just you want to get it up and running. You just put in the simulate just to get by the initial startup sometimes. But and then you'll get this blue symbol. So anything in blue means it's in simulate mode. Grayed out is what? Open or closed?
Gray is closed.
Closed. So anything with the colors.
Green is
green,
open.
green is open.
Red means fast.
Red means alarm.
Yep.
So not sure what. Let's put that back to auto. So in order to run the system, now we have alarms in here. You can see. Okay, here's the alarm here, and we got high levels in the excuse me in the membrane tank. Now you can go to alarm summary. And then you can see membrane tank level high, average tank level high. So those are the kind of the current alarms. Now you also have alarm history. So you can go back, even though you cleared it on the alarm screen, it'll still show up in alarm history. So here we had blowers not available because they had it in manual off, insufficient blowers saying, hey, we don't have enough blowers. Because you can have one off, one on, but it'll still say whatever, blower may not be available, but one will run, but you'll still have, but if you need two, it'll generate that alarm saying, hey, insufficient blowers. So if you don't have enough blowers, it'll say, hey, I got to either shut down one train and continue that way. It won't totally shut it down, but it'll give you, but if you got no blowers running, it's not going to let you run it no matter what. You got your communication lost, some PLC. Here's a system stop alarm. So some alarms reset themselves. It's like levels will probably reset and clear, restart. Others require, so here's the system stop. So you got system stop alarm. Now, you've already pulled it, but that kind of alarm requires a reset. So now you reset it, it goes gray and it's clear. So the red guys are still in place, either acknowledged or unacknowledged. Oh, God. So here you can see, you go to the alarm screen, you got a bio alarm, UF1 alarm, UF2, so those, something here. So this tells you got a bio alarm reset. Here's the UF1 reset. So let's go to the bio screen. It's got to be. So do we have any alarms? So we got average bio. Yeah. So we got these current alarms in there. So you hit reset, they're just going to come back. So obviously, if they're not cleared, they will. So like this average alarm will probably clear once we get water moving through it. So it's saying high level is 120. We're at 124. Hence we got the alarm. Okay. Let's see if you guys remember. So what state do we want to put the train in?
What's actually running?
So what state do we want to put it in? So we're in mode is off. So we want to put it in automatic.
Yep.
So to do that, you got to be logged in.
Yep. Remember,
because we weren't logged in. We went here and there's nothing showed up. So now everything shows up. So you have auto mode, off mode, and semi-auto mode.
It's auto mode.
So we want to put it in auto mode. So right now it's selected for back pulse and not relax. So if you choose relax, it'll highlight that. So if you put it in semi-auto, all these buttons now come available. You can prime it. So if you hit prime, it'll run the ejector valve saying 60 seconds. It'll run that. So now you'll see the vacuum being generated. So it's going to increase the vacuum on the pressure transmitter was higher. And so this is the pressure inside the membranes. So ideally, if the parameters are correct, the TMP pressure when everything is primed, that should be 0. Because that indicates that, right at the membrane it's 0. But in that pipe, we got minus 2.8. So minus 2.8 at the top of that header where that pre pipe is. That's how much vacuum we have on it. So when it starts up, it'll pull that water through because we have almost 3 psi of vacuum pressure on this line going to the pump. So ideally, we're close to that. So 8 seconds. So it times down. 5, 4, 3, 2, 1. And remember, it's in semi-auto, so it goes just off and sits there and waits. So if you want to do a clean, you hit clean and it would do a clean and stop. You can do neutralizations, back pulses. Okay, so other things on here. So right now, there's a train schedule. So the only thing scheduled, he's got Wednesday's maintenance clean and a chlorine clean. All your set points. So these set points will show up on a number of locations. So you can get it from here. If you hit set points here, train set points or process set points. So they show you can get through set points in a number of different locations. So it's not just one place that you can get at it. So there's your train set points. Those are your membrane tank. So these are train related. The train set points are common to both trains. So it's not like you can, I'll set train 1 at high level at 116 and then UF2 at 120. No, they're designed the same, so they should have the same set points. Even though sometimes it's nice to have different set points. But this here is common set points for the trains, because that's the train. So you got your tank levels, your turbidities, common, your pressures, your transmembrane pressures. This is an indication of how good the membranes are responding, how clean they are. And then your permeate and back pulse flows, high-low flows, alarms, cleaning alarms for flow. So you got process set points. These are common set points for cleaning, priming directions, back pulse, all that, RAS set points. So these are all for both both bioreactors and membranes. So this is your UF demand screen. So the demand is created by this incoming feed flow moving average plus the trim demand. So it's looking at, I guess there's a flow meter that's sending us how much water's coming in the plant. And then we're looking at, this trim is based off of the, where's that zero? Okay, it's based off the level in the post-anoxic zone. So as that level goes up, we want to speed up the train. As it goes down, we want to slow it down. We don't want to be stopping and starting trains constantly. It's based on that level, so we want to slow it down a bit. We prefer to have it constantly running than run full out and stop, full out, stop, full out, stop. We'd rather have it running at a slower speed and running constantly rather than stopping the whole thing always. Okay, so when you lose power, there's a whole sequence where you lose power and then power comes back on. We don't start everything up all at once. We start up the utilities, we start up train 1, train 2, CIP, all that gets sequenced in, so it slowly powers up. So it's not all of a sudden, boom, you got 6 motors running and everything trying to run at the same time, blowing fuses and all that, so it's all sequenced and powered up. There's your bio set points. If you're doing micro C on time, so it says 15 minutes on, 15 minutes off. A trigger to tell, okay, if the flow is just above 50, turn on micro C. So that it's got all these speed references for the mixers. So all this is the bio set points. D-night flow max flow factor. So the flow factor is, okay, run at 2.5 times the incoming flow. So there's a whole pile of things. And then there's your alarms, DO alarms. If it's above 4, alarm, below 1, alarm. And if the deviation is greater than 0.5, create an alarm. We got this special thing because freeze rotation, sometimes in the wintertime, things get cold, so you don't want to have things stagnant. So if you choose freeze protection, it says, hey, if the train's off for greater than 30 minutes and there's a demand, hey, run the train, then rotate them quickly. Because normally they're going to rotate on train rotation right now, they're set for 1 hour, but in the middle of winter, you may want to decrease that. So that's what this freeze rotation does, say, hey, rotate it. It says here, run the train for 200, so that if the train's been in standby for, 30 times 60, 30 minutes, run the train for at least 200 seconds instead of waiting for an hour and things get frozen up. So hopefully not, but that's what that freeze protection is. Normally it's going to be timed, and you can make it anywhere between 0 and 72, but usually it's a couple hours or something. These are all these tuning set points. Those should be set. You won't have to really, what this is your tuning parameters. So if you have a set point of 300 and the pump's going 400, 100, means the tuning parameters are out. You want a pretty steady line once it's established within 30 seconds or so. You want that set point and the process variable being matching. If they're not, that's where these tuning parameters come in to try to adjust how the P90 racks. But they've got all that as well. So remember we had our ejector, there's the ejector. You got your pressure transmitter, that's the one that was on the skid. You got your pump, you got your turbidity system here, so there's your 2 valves that provide the water for that. You got your level switches, level transmitter, and then there's your 2 chemical valves. And they're giving you the train flux and train permeability. So this gives you an indication of how well your train's working. Because the T&P alone, so if you have a flow, say 100, but then you go to a flow of 200, what's going to happen to your T&P? So you're 100, and then the T&P goes up or down if you go to higher flow, you figure.
It goes down, wouldn't it?
Yeah, go lower negative, right?
Yeah.
But that's not necessarily, so you go, I'm used to seeing a T&P of -1, and I'm seeing now -2. Oh, my membrane's getting dirty. Not necessarily. If you're running at a higher flow, you're going to have the T&P. That's why the permeability is a more important thing, because it takes into account the flow, the pressure, and the area and everything. So you get a flux, but then the permeability takes into account all those, the pressure, the flows, and the area to give you a better number. And it's also temperature corrected, so because in wintertime, what's water? More viscous? It'd be harder to...
Less viscous.
Is it easier to...
It's harder to move.
Harder to move, right? So you're going to have a higher T&P in the wintertime. So that permeability, I don't know whether that's temperature corrected, takes into account the temperature, say, okay, no, you're fine. Or T&P, yeah, you're running kind of the same flow. You go, yeah, T&P looks good. But then they give you a bit more info. You get your flux, but flux is gallons per foot per day, but it's actually the gallons per foot per day per PSI, which takes into account the higher flow. Obviously, you're going to have higher pressure, and that number there is probably the best number in terms of your membrane health to look at that. A day to day, you just look at because you know what your pressures are, your flows are. So yeah, that looks good. Oh, that starts approaching -5, 6, 7. There's whatever. It's time to do some cleaning. So process pump. So you have forward, reverse, and auto, because